Hello everyone. Today we will discuss few problems on projection of lines. So before starting these problems, I would like to explain about the scale which we use as well as certain colors codes for the projections of line. So the unit what we use here is AutoCAD unit, and one AutoCAD unit we divide into 4 parts. That's why our grid setting and snap setting is 0.25. That means we divide one AutoCAD unit into 4 parts, and we take one AutoCAD unit is equal to 100 millimeters. Since we divide it into 4 parts, the distance between each grid space is nothing but distance between 2 dot points, it is 25 millimeter. So our unit will be the distance between two grid points, that is grid spacing, is equal to 25 millimeters. Color codes whatever we will use in the projection of lines will be XY line, front view and top view of the line we will show with the black color or white color depending on the background. For example, presently the background is black, so white color will be the by default color. If background will be white, then black color will be the default color. All projections lines, locus lines we will show with the cyan color, and true length we will show with the yellow color. So let us begin with the problem. Line CD inclined 30 degrees to VP, has its end C 25 millimeter behind VP and 25 millimeter below the HP. The distance between the end projectors is 150 millimeters, with the end D 150 millimeter below the HP and is behind the VP. Draw its projections and find the true length. So in given example, the line CD is given, which is inclined 30 degrees to VP. So inclination of line is given, that means true inclination is given. So the line is inclined 30 degrees to VP, that means it is angle phi. One end of the line, that is end C, is completely specified, that is it is 25 millimeter behind VP and 25 millimeter below the HP. So below HP and behind VP, that is description of point in third quadrant, that means point C is in third quadrant. The distance between the end projectors is 150 millimeter, with end D 150 millimeter below HP and behind VP. So how much millimeter it is behind VP, that is not specified, but it is given that it is 150 millimeter below HP. So point D is also in third quadrant, and we have been asked to draw the projections of lines and find its true length. So let us first draw the XY line. So XY line is drawn. Then we will mark the point C, which is 25 millimeter behind VP and 25 millimeter below HP. So we know the description of point in the third quadrant. Top view it will appear above the XY line, front view will appear below the XY line. So we have specified top view and front view of the point. We can name it. So this point is capital C as well as small c. What I can write? This other point is capital C prime and small c prime. And we can join the projector line passing through the point. As I said, all projectors line we will show with the cyan color. Then position of point D is given, it is 150 millimeter below HP. So what we can do, we can draw the locus line for D 150 millimeter below HP. So the locus location is given from XY line 1 to 150 millimeter means total 6 grid space. Distance between two grid point is 25. So I will have to count 6 grid space here. So we'll count 1, 2, 3, 4, 5, 6, and we'll have to draw this line. So this is nothing but locus of small d prime. Then distance between end projector is given 150 millimeter, that we can draw the end projector. One projector which is passing through points C and C prime, second projector it will pass through the point D and D prime. So I will draw the projector. Which is 150 millimeter away from this projector. 1, 2, 3, 4, 5 and 6. From this point, this is end projector is drawn. So we get the point D prime, which is the intersection of end projector and locus of D. So this point is nothing but D prime. Okay. So we can join the point C prime and D prime, which is nothing but front view of the line. So we obtain front view of the line. I will draw another line where true length of the line will be seen. It is given that the line is inclined 30 degrees to VP. That is, true inclination of line is given. So true line we will show with the yellow color. So I will draw an arbitrary line. Since true length is not known, we will draw an arbitrary line and we will rotate it at an angle 30 degrees. So on this yellow line, we will have the point capital D. Now, if you remember the steps which we discussed for the skew line solution, if suppose we have the point small d prime, then how to obtain point capital B. So what we do, we rotate the point D prime and obtain the point D1 prime, and then we will have to project that point. So we will rotate the point till the locus of C prime. So I will have locus for C prime. I will have to rotate the point D prime with center C prime. That we can rotate it. So this point is nothing but point D1 prime. Okay. So here, since we get the point D1 prime, now I will have to project this point, and we know the point capital B is on the yellow line, which is at an angle 30 degrees. Okay. So we will project the point till this point, and we can just do the better finishing here by trimming the lines. So I want to trim the excess lines. This point is nothing but capital D, and I can draw the line passing through point capital D. Okay, and this is nothing but locus of D. Okay. And the intersection of end projector with the locus of D will be nothing but point small d. So this is point small d. Okay. And projections with the bilayer color. So these are the projections what we obtained, and we have been asked to determine the true length of the line. So true length we obtain, that is capital D, capital C is capital D, that we can measure with the dimension command, or I can use a list command here, and I can find the length of the line is 2.2546. So it is in terms of AutoCAD unit. So 2.2546 is AutoCAD unit, and I said that one AutoCAD unit is equal to 100 millimeters, and we divided one AutoCAD unit into 4 parts. That's why distance between two grid point is 25 millimeter. So here it is AutoCAD unit 2.2546 millimeter. So multiply by 100, we will get 225.46 millimeter. So in projection of lines, we will write the answers in separate box. So I can write the true length TL, simply I can write TL, which was equal to 225.46 millimeter. This is answer. So separately we will write the answer with the bilayer. So this way we can solve the problems which are given on the line. Second problem we will discuss. End A of line AB is 50 millimeter above the HP and in front of the VP. End B is 150 millimeter above the HP and in front of the VP. The front view makes 45 degrees with the HP. VT is 175 millimeter above the HP and HT is 125 millimeter in front of VP. Draw its projections and find the true length and true inclinations. So for this problem, point HT and VT are also given. So line AB, one end A is given 50 millimeter above HP and it is in front of VP, but no information how much distance in front of VP. but it is sure that point A is in first quadrant. Point B, it is again 150 mm above HP and in front of VP. So point B also half information is given, point A is also half information is given. So point B 150 mm above HP and in front of VP. So it is also in first quadrant. And front view of line is given, it makes 45 degrees angle with the horizontal plane, that is angle alpha is given, apparent angle alpha is given. Vertical trace it is given 175 mm above HP. Now vertical trace, that is VT point, it is always in vertical plane, intersection of the line with vertical plane, and it is either above or below the HP. So in this given case it is 175 mm above the HP. Whereas horizontal trace, it is a point which is always in the HP, and it is in this case it is given, it is in front of VP, 125 mm in front of VP. So from here, from the given information, we will be able to plot front view of point A, then locus of front view of point B, then we will be able to plot the locus of VT, locus of HT, as well as we can draw a line which will indicate front view and which will be at an angle 45 degrees with XY line. So let us start the problem. XY line, let us plot the point front view of point A 50 mm above HP, this is point, we have front view, that means A prime, same prime point is capital A prime, and I can draw the projector line through it for on this projector line there will be point small a, but we do not know the position. Similar way we can draw the locus for point B prime, which is 150 mm above HP. So we can draw the line 150 mm above the HP. It is locus of B prime. Then we know the front view, I can draw an arbitrary line which will make the at an angle 45 degrees. Intersection of this line with the locus of B prime will give point B prime. So we can rotate this line at an angle 45 degrees and we obtain the point which is nothing but B prime. So this point is B prime. So we got the front view. Well, next part here we can draw here locus for VT as well as locus for HT. So VT is given 175 mm above HP. So I can draw the locus for it. Similar way, HT is 125 millimeter in front of VP. So this is nothing but locus of VT. This point is nothing but locus of HT. Okay. So we have plotted the information. Now the important thing which is to be seen here, that HT and VT, we know the H prime point is a front view point and all front view points are collinear, and H prime point will be always on xy line. So I can extend A prime B prime till xy line and obtain the point H prime. Extend this point and this point will get, it is nothing but H prime. This point is nothing but H prime. And top view of H prime is nothing but HT, which will lie on the locus of HT. So top view of H prime is nothing but HT, which will come on the locus of HT. So we have to simply draw the projector line. Then we will do the better finishing for this line. Since this is the extended line, I will simply draw a line which is cyan color line. So projections is A prime B prime and that line is extended to obtain the H prime. This point is nothing but HT. Now other information what we have here is VT is also front view point and small v is the top view point, and we know all front view points are collinear. So we can extend the line A prime B prime till the locus of VT, we will get point VT. So we need to extend this line till the locus of VT. So this point is nothing but VT. And we can draw the projector line from VT till xy line, that is point small v, because small v is the top view of VT and it will be always on the xy line. We do better finishing here also by trimming this line. This point is small v. Now coming to the top view, we know HT and small v are the top view points. We can just draw a line which is joining HT and small v, and what we can do, we can obtain the point small a. How we will obtain? The line joining HT and v, it will intersect projector passing through a prime. That intersection is nothing but point small a. So this point is nothing but small a point. Similar way, projector passing through b prime, it will intersect the line joining the all top view points, will be nothing but the point small b, because small b is the top view point. So well, we'll do the better finishing here by trimming the line and changing the color. So well, our projections are done here. Now we have been asked to determine the true length and true inclinations. So true lengths, but we'll have only one true length. In front view and top view, we'll obtain the two true lengths, but both will have the same value, or both should have same value. So let us find the true length first and inclination in front view, that is theta. So for that purpose, what we have to do, we have to obtain the point capital B prime. We have the point small b, and how to obtain the capital B prime from small b. So we have to rotate the point small b till the locus of small a, that is nothing but the point B1. Then we have to project that point on the locus of B prime, that is the point capital B prime. So let us draw the projector line passing through point A, that is locus of E. Then we will rotate the point B prime. This point, what we get is B1. Now project this point till the locus of B prime. So this point is nothing but capital B prime. Join capital A prime B prime, that is nothing but the true length. Which will indicate it with the yellow color. So true length we obtained, true inclination also we can measure for this line, that will get angle theta. So here I will just find using the list command. I get the line is 1.5844, that is in terms of AutoCAD unit, just multiply by 100, it is 158.44 and its inclination is 39 degrees. Okay, so that is theta. So I can write here detect with detect command true length of the line which was 158.44 millimeters inclination with HP is equal to 39 degrees. Okay, so these two information we got, but we want true inclinations, that is the inclination with HP VP also we want, that this we got theta. Now we want phi also. So for that purpose we should obtain true length in top view also. That means we know the point small b1 prime, from small b1 prime we should obtain the point capital B. So how to obtain it? We have to rotate b1 prime till the locus of A prime, that is nothing but the point b1 prime, then we have to project that point till the locus of B. So let us first draw the locus. Similar way we require locus of B. Now rotate the point b1 prime. till the locus of A prime, that point is nothing but B1 prime. Now project B1 prime on the locus of B. This is nothing but point capital B. Join capital A, capital B. Capital A will be here. It will be shown with the yellow color. And inclination also we can find out. We can use the dimension command or list command. So here you will find the length is equal to 1.584, that is 158.44. That is true length, and it is obvious it will not change, right? And angle inclination is 27 degrees, that is angle phi, inclination with vertical plane. So true length will be remain same, that means our solution is correct. Okay, so I can write the inclination with Vp is equal to 27 degrees. So this way a complete problem can be solved. Thank you very much.